Hi friends, this is Dr. Karuna Kumar from Andhra Loyola College Chemistry Department. I wholeheartedly welcome you to this particular session wherein we are going to discuss a very important topic in inorganic chemistry, namely oxides and oxyacids of sulphur. This is present in first BSc chemistry course of recently held APCHI BSc honors course curriculum. Now, what are oxides of sulphur? The binary compounds of sulphur with oxygen wherein the oxidation state of oxygen is -2 are called as oxides of sulphur. So, there are several oxides of sulphur. Out of them, the significant oxides of sulphur are sulphur dioxide, namely SO2, and sulphur trioxide, namely SO3. Now, how do you prepare these oxides of sulphur? Sulphur dioxide can be easily prepared by igniting sulphur with insufficient amounts of oxygen to give you sulphur dioxide like this. This is a simple method by which one can prepare sulphur dioxide. The second method for the preparation of sulphur dioxide includes any ore of sulphide like iron biarate or silver sulphide, anything you can take and then you ignite it in excess of oxygen, then we are going to get an oxide of silver and also an oxide of sulphur. So, in this way sulphur dioxide can be prepared. This is the second method for the preparation of sulphur dioxide. So, sulphur trioxide is obtained by treating sulphur in excess amounts of oxygen, like take 2 sulphur, 3 moles of oxygen, you are going to get 2 SO3. This is sulphur trioxide gas. Out of sulphur dioxide and sulphur trioxide is more acidic in nature. So, we know very well acidity of any oxide can be easily determined with the help of a litmus test. Anything which converts blue litmus to red is an acid. So, both these oxides are acidic in nature. Out of these two oxides, SO3 is more acidic. Now, when we look at the structure of SO2 and SO3, both of them are having sp2 hybridization. So, let us focus on the structure of SO2. In SO2, the central atom is sulphur. We know very well the terminal atom, namely oxygen, forms 2 bonds with each sulphur. Sulphur belongs to 6th group. Oxygen, sulphur, selenium, tellurium, polonium, etc. all of them belonging to 6th group. So, they have 6 valence electrons. Out of the 6 valence electrons of sulphur, only 4 electrons are utilized for bond formation. Therefore, 2 electrons are remaining on sulphur. So, this is a lone pair present on sulphur in sulphur dioxide. How many bond pairs are there? There are 2 bond pairs. Why there are only 2 bond pairs, though there are 4 bonds here? Out of these 4 bonds, only 2 are sigma bonds, the remaining 2 bonds are pi bonds. Only sigma bonds are considered as bond pairs. Therefore, there are 2 bond pairs and 1 lone pair. Totally there are 3 electron pairs. So, because there are 3 electron pairs, there should be 3 orbitals undergoing hybridization. So, as a result, it undergoes sp2 hybridization. Because of this particular sp2 hybridization, we are going to expect a trigonal planar shaped species like this. So, sp2, sp2, sp2 hybrid orbital, and this hybridization has taken place on sulphur. Now, oxygen, the atomic number of oxygen is 8, half filled 2py orbital of oxygen is overlapping with sp2 hybrid orbital of sulphur to form a sigma bond. So, totally there are 2 sigma bonds formed in this direction. So, and there is 1 lone pair like this. So, totally the shape of this molecule is angular with a bond angle very close to 120 degrees. So, the hybridization is sp2, the bond angle is 120, and then there are 2 sigma bonds like this and 2 pi bonds like this. Now, these 2 pi bonds are not of same kind, because one pi bond is formed by the p pi overlapping, the other pi bond is formed by p pi d pi overlapping. In SO3 the central atom is sulfur. There are 3 terminal oxygen atoms like this. Now each oxygen generally forms 2 bonds. Yes, sulfur belongs to 6th group in the periodic table. So it has 6 valence electrons and it is forming all 6 bonds here. Therefore there are no electrons left on sulfur. So 0 lone pairs. How many bond pairs? I told you only sigma bonds are considered as bond pairs, and between any 2 atoms if there is a double bond only one of them will be sigma bond, the remaining bond will be pi bond. So therefore I have only 3 sigma bonds here. So 3 bond pairs. Total number of electron pairs is equal to number of lone pairs plus bond pairs. So 3 electron pairs are there. So therefore 3 orbitals must undergo hybridization again. So it is sp2 hybridization. Whenever sp2 hybridization is taking place, we are going to get a trigonal planar shaped species like this with a bond angle of 120 degrees. The central atom is sulfur. The terminal atoms are oxygens. So each oxygen generally forms how many bonds? 2 bonds. So one is a pi bond, the other one is a sigma bond like this. Fine. Here also there are 3 pi bonds, but all these 3 pi bonds are not formed due to same p pi overlapping. Only one pi bond is formed by p pi overlapping. The remaining 2 pi bonds, they are formed by d pi p pi overlapping. D orbital of sulfur is overlapping with a p orbital of oxygen in a sidewise fashion to give you this t pi p pi bond. So d pi p pi bond. So there is no disparity in this particular SO3 structure. Why? Because there is no lone pair. Unlike in sulfur dioxide where we have one lone pair due to which the shape is reduced to angular. Now in SO3 there is no lone pair, hence the shape of the molecule is not distorted. We are getting the same trigonal planar shaped species. Now when we move on to oxyacids of sulphur. What are oxyacids of sulphur? I told you oxides of sulphur are binary compounds of sulphur with oxygen, wherein we are having an oxidation state of oxygen as -2. But what are oxyacids of sulphur? Oxyacids of sulphur, very important. They are compounds of sulphur, hydrogen and oxygen. There are several types of oxyacids of sulphur. Out of them 4 classes are very important. Number 1 acids, number 2 acids, number 3 thioacids, and the last one is peroxoacids. So what are the acids of oxyacids of sulphur? Sulfurous acid, which is nothing but H2SO3, sulfurous acid. Acids example, sulfuric acid H2SO4, which is also called as king of chemicals. Thioacids, thiosulfurous acid H2S2O2, thiosulfuric acid H2S2O3. What are peroxy acids? Peroxy acids are oxyacids of sulphur containing a O single bond O linkage. So they are nothing but H2SO5, which is also called as Carros acid, and H2S2O8, which is also called as Marshall's acid. So these are several oxyacids of sulphur. All these oxyacids of sulphur, they contain 2 OH bonds. Therefore all the oxyacids of sulphur have basicity 2. For example, if you look at the structures of sulfurous acid and sulfuric acid in particular, the central atom is sulphur and we have 2 OH bonds as I told you already, and there is only one oxygen left over here. So H2SO3, this is the structure of H2SO3 sulfurous acid. Now what about sulfuric acid? Sulfuric acid, the structure will be like this. So this is the structure of sulfuric acid. So if you carefully observe the basicity, namely number of replaceable hydrogens present in any oxyacid, is here it is 2, here also it is 2. So there are 2 replaceable hydrogens. Therefore, the equivalent weight for this molecule will be molecular weight of sulfurous acid divided by 2. Here also the equivalent weight is equal to molecular weight of sulfuric acid divided by 2. So, molecular weight of sulfuric acid is 98. So, by 2, that is equal to 49. So, equivalent weight, though the formula is representing molecular weight by 2, molecular weight by 2, but the molecular weight of sulfurous acid and sulfuric acid are not same. Hence, we are getting different equivalent weights for these two oxyacids of sulphur. So, sulfurous acid, sulfuric acid. Now, we move on to the next class, namely thioacids. So, if you look at the thioacid, I told you thiosulfurous acid, thiosulfurous acid, very in a very easy manner one can draw the structures of thioacids, because in thioacids you simply replace a double bond O of sulfurous acid or sulfuric acid with a double bond S. First, let me draw the shape of sulfurous acid again. Let me draw the shape of sulfurous acid again. So, this is the shape of sulfurous acid. Now, I told you remove the double bond O with a double bond S. Now, this is going to become H2, S2 and then O2. So, this is nothing but thiosulfurous acid. So, once you know the S acid or ic acid structure, it is very easy for you to determine the thioacid structure in this manner. Now, thiosulfuric acid, what is the structure of sulfuric acid? This is the structure of sulfuric acid. Now, thiosulfuric acid, you replace one of the oxygen with a sulfur atom like this. Now, this is called as thiosulfuric acid, whose formula is H2, S2, O3, finish. This is thiosulfuric acid. The last one, I am concluding the session with the last oxyacid of sulphur, namely the Karose acid. This is an example for peroxo acid. The formula is H2SO5. For this, the structure will be S double bond O, OH, double bond O, OOH. So, this is the so called peroxy linkage. O single bond O linkage is called as peroxy linkage. So, because it is containing a peroxy linkage, it is called as a peroxo-oxyacid of sulphur. This is Karose acid. Another example for this particular type of oxoacid is Marshall's acid, whose formula is H2S2O8, where we have a peroxy linkage between two sulphur atoms like this. So, if you look at this structure, even here there are only two replaceable hydrogens. What type of hydrogens are replaceable? Hydrogens highly attached to a highly electronegative atom like oxygen are replaceable. Therefore, it is having equivalent weight as molecular weight by 2. So, thank you very much. This is the conclusion for oxides and oxyacids of sulphur.